Now we're going to perform a test of hypotheses for the difference between two proportions. So let's say we have a random samples. My first sample size is 60. So that's N1 is 60. My second sample, the size of my second sample is 70. You guys see N2 70. Were drawn from populations 1 and 2 respectively. Now the samples yield P1 hat of 0.6 and P2 hat of 0.6. So the average on my first sample was 0.6. My average on my second sample was 0.6. Let me write some information before I continue. Okay, so I stop reading right here. Okay, that's where I stop reading. So let me take a look at here. First of all, I'm gonna say some information that I have to copy down. My P1 is 0.6. My Q1 gonna be 0.4. Remember, for my Q value, I just go 1 minus my P value. So 1 minus 0.6. And then my sample size on 1 was 60. My P2, I'm looking for P2 hat, it was 0.6. My Q2 hat, or my Q2 is 0.4, because remember I went 1 minus 0.6, and my N2, the numbers in my second sample were 70. Okay, so I have that information. Now let me continue reading. It says test the null hypothesis that P1 minus P2 is 0.01. Okay. Against my alternate hypothesis that P1 minus P2 is greater than 0.1. And I'm going to be using our 0.01 alpha, okay? So first of all, I'm going to say, based on this number, P1 minus P2, I'm going to say my difference on my null hypothesis is going to be 0.1. I'm going to use this number here, okay? Now, let's take a look at the formula I'm going to use to find my test statistic. Be careful on how you type it. It's going to look like a funky formula, so be careful when you type this, okay? It's going to be, first of all, I'm going to go P1 minus P2. I'm going to put this inside parentheses. So P1 minus P2 minus my difference of my null hypotheses over. So this is going to be over a fraction. Good thing we have a new calculator. This is going to help us type things in. And then over at the bottom, I have to find out what's the standard deviation of P1 minus P2. For right now, don't copy what I'm going to copy at the bottom of my fraction, okay? I have to find out what's my standard deviation of P1 hat minus P2 hat. Now you guys are going to be wondering, how do I get the standard deviation? Right, let me erase this. Let me show you guys how to get the standard deviation. It's going to be a square root. Inside the square root, I'm going to have two fractions. And as a matter of fact, I'm going to be adding the two fractions inside the square root. My first fraction is going to be P1 times Q1 divided by N1. My second fraction is going to be P2 times Q2 divided by N2. I'm going to type this in on my calculator, and I should be able to figure it out. So let's see. Let me share my calculator. Again, you guys can have access to this calculator using the link on the left side of Canvas. So, okay, so I have a fraction, right? And then to begin with, I have a parentheses. It was P1 minus P2. According to my notes, I have 0.6 minus 0.6, close parentheses, minus my difference of my null hypothesis, which was 0.1. Let me click down. So on my arrows, I click down on this bottom part of my fraction, but I know the bottom part is square root. And remember, I have two fractions with a plus in between. So let me do my fraction plus my other fraction. Make sure all of this is inside the square root, okay? I'm moving my arrows to be able to go back and forth. Okay, on the first fraction, remember I have P1 times Q1. So 0.6 times 0.4, and then divided by N1, which in my case was 60. Let me move my cursor. So on the second fraction, remember I have P2 times Q2. So 0.6 times 0.4. At the bottom, I had N2, which is 70. I typed everything. The cool thing is, look, my calculator, it was working everything out. Nice. So my test statistic is a negative 1.16. Now let me find my p-value. Okay, so I'm going to be using my test statistic here, my p-value. According to my C-score table, like I said, I did not give you guys the C-score table because you guys should have it. We dealt with it before. I'm gonna look for my probability with a 1.16, and I get 0.377. Right, this is what I found on my table. Remember, I saw my 1.16. I know I have a negative here, but I saw 1.16, and that gives me 0.377. However, for me to find my p-value, I have to do 0.5 minus 0.377. And this gives me 0.123. When I'm reading my instructions here, it says round to 4 decimal places. Oh, okay. So I'm going to have 4 decimal places as needed. Just to double check, on the previous one said round to 2 decimal places. So good, I got it 1.16. Now, what is the appropriate conclusion of the hypothesis test at 0.01? What I'm going to be doing is I'm going to compare my alpha and my p-value. I'm going to compare my alpha with my p-value. I know alpha is 0.01. My p-value is 0.1230. So again, this is 0.01 and this is 0.1230. Which one is bigger? Is my alpha bigger or my p-value is bigger? Yeah, my p-value is bigger. Every time p-value is bigger than alpha, do not reject the null hypothesis. If my alpha was bigger than my p-value, then in that case, do reject the null hypothesis. But now here, because my p-value is bigger, I'm going to say do not reject. Let me write, do not reject the null hypothesis. Again, because p-value is bigger than alpha, do not reject it. There is, I'm going to write, there is insufficient evidence to indicate that remember while we were testing, remember while we were testing on the alternate hypotheses, the P1, the minus P2 is greater than 0.1. That's what I was checking. So that is what I'm going to finish here. to indicate that P1 minus P2 is greater than 0.1. You know, your homework, most of them, you're going to find your test statistic, run it to 2 decimal places. You're going to be dealing with your p-value, and you're going to compare your alpha with your p-value. You should know whether you reject the null hypothesis or do not reject the null hypothesis.